One of the worst tornadoes in decades rips homes, schools, and families apart.
It's blowing and sucking the air out of the room.
In May 2013, an EF5, the most severe category of tornado, strikes Moore, Oklahoma. The 200-mile-an-hour winds slammed into a school, killing 7 children. Up to then, spring 2013 had been a quiet season. But just 2 years earlier, 2011 was the 4th deadliest tornado season on record. Over 150 die in one city alone, Joplin, Missouri.
Houses are gone. It's massive.
What can be done to prevent such disasters in the future?
We have to figure out a better warning system.
But a better warning system requires a better understanding of tornadoes.
There's an urgency to try to crack the code. So we have to keep going and get data as often as we can.
And all that data could lead to better prediction and save lives.
To see so far in the distance and there be nothing, like someone dropped a bomb.
NOVA follows the scientific investigation into the most dangerous tornadoes in recent times.
Something you don't ever want to have to live through ever again.
Through survivors and their stories, scientists and engineers, we examine these devastating events and the effort to prevent future disasters.
There's more supercells dotted down the line all the way through North Texas.
By deploying new technologies to warn people earlier in life or death situations.
They love the weather here. Well, you know, if they don't pay attention, they die.
The race is on to understand one of nature's greatest mysteries. Relive Oklahoma's deadliest tornadoes right now on NOVA.
Major funding for NOVA is provided by the following. The David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. The Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
It's a beautiful day in Oklahoma. The sun is up, the sky is blue. But suddenly, the weather takes a turn for the worse.
The weather is beautiful, but then just as you can snap your fingers, it went bad.
It's May 20th, 2013. Tornado season is well underway, but it's been unusually quiet. Until now.
It looked like there would be severe thunderstorms and some tornadoes.
The tornado watch was issued for a swath of central Oklahoma. We know that that area will likely have a tornado, but we still don't know exactly where.
Still concerned with the risk of tornadoes.
More severe weather possibilities.
This darkening sky is about to bring chaos, death, and destruction to the city of Moore.
That's crazy.
What is about to hit will be one for the history books.
The thunderstorm formed to the southwest of Oklahoma City. I was very concerned.
That storm grew so quickly, it's like it created its own weather system. It created what it needed to grow.
We could see on radar that it began to produce a hook and a vortex signature.
Just before 3 p.m., all eyes turn to the heavens as a funnel cloud drops toward the ground. It's a chilling sight.
There it is, there it is.
It's forming. It hits ground.
Soon, tornado sirens are sounding all over the nearby city of Moore.
It was in its infancy stage. It was growing and it was powerful, and all the energy's feeding into it, and the winds were ideal to produce a very large, deadly tornado. It just was that little ribbon, and it just got larger and larger and larger.
Okay, I'm right here by it.
Okay, maybe talking to you here in a little bit. Hang on.
At 3 p.m. in the afternoon, and the tornado's on the ground, moving into Moore.
The wind speed accelerates to 150 miles an hour as it moves rapidly across country.
What was amazing to me was the rapid growth of the system from probably 65 mile an hour, all the way to close to 165 in just a matter of minutes.
Oh my God!
This tornado will be on the ground for 40 minutes and will cut a swath of destruction over a 17-mile path.
Holy moly, that's insane! It's huge!
It's a large and deadly tornado, and it's getting stronger.
Near the core of that tornado, your wind speed may be approaching 200 miles an hour. A giant, violent circulation.
I hope everyone's okay.
Within minutes, hundreds of homes are destroyed. Now nature's fury has turned its sights towards even more vulnerable and precious targets. Briarwood Elementary School in Moore takes a terrifying hit as winds exceeding 200 miles an hour rip it apart. Miraculously, all its staff and children survive. But at nearby Plaza Tower Elementary School, terror turns to tragedy as 7 children die, despite the heroic efforts of their teachers to shield them from harm.
The building was collapsing on some of us and we heard glass shattering. We laid on top of our kids and we did whatever we could.
Oh God, there's so much debris in the air!
Soon afterwards, the tornado plows into the Moore Medical Center. The roof and upper floors are ripped from the building, but patients and staff survive.
This is right now, it's part of the damage is occurring right along 19th Street and Moore. It's occurring on Penn Lane.
I think I've seen 2 cars get picked up off the bridge and thrown in the air. This thing is violent. It's so big I can't fit the whole thing in my viewfinder.
Finally, about 40 minutes after the tornado touched down, it clears the city limits. Then, soon after, weakens and dies out.
Houses are leveled.
In this city of almost 60,000, the tornado claimed 24 lives, including 10 children. Nearly 400 others were injured. It left behind a trail of destruction and damaged or destroyed 12,000 homes.
I got trapped when it came in and hit us. We made it out of there. We have some bumps and some bruises, but we have our life, and nothing is better than that. And I look at this as a testimony. I survived a tornado at the age of 28. I am able to walk, breathe, and live. I may have a broken arm here, but God knows this right here, this is amazing.
All the kids are going crazy and screaming, and like I got 2 of them on my lap and the other 2 are holding me. And I got my arm around my son and he was like, Mom, what do I do? I'm scared. And I was like, just pray.
Last time my daughter saw her cat was Monday morning before she went to school, and that was, now we found her in the rubble. I'm gonna bite my nose now.
This was a disaster because it had a direct hit on a densely populated area.
My bathtub saved my life. We survived in this tub. Of course, like I say, it didn't have all this debris in it then. I could hear it. Definitely you can hear it, because one that size and the ground was just shaking, like an earthquake. It was just shaking. And then I heard the cracking sound of the roof lifting off the house, and then I guess the house kind of imploded.
As battered Oklahomans emerge from the aftermath, scientists race to figure out exactly what happened. Just 10 miles from Moore, Oklahoma, is the town of Norman, site of NOAA's National Severe Storms Laboratory. Predicting and issuing timely advance warnings for tornadoes is the holy grail of scientists here. For them, the first step after an event like this is to understand exactly what happened. Their instruments tell them that the Moore tornado had wind speeds exceeding 200 miles an hour, grew almost 1.5 miles wide, and stayed on the ground for about 40 minutes. First estimates put the cost of the damage in excess of $2 billion. These terrible statistics make it one of the most damaging twisters on record. But even so, for a storm this size, the Moore tornado resulted in relatively few casualties. The fatalities were heartbreaking, but the toll could have been much higher. Many were spared because the tornado first touched down outside of town, giving residents time to get to safety. And advanced notice is essential to saving lives. Meteorologist Greg Carbon coordinates warnings at the Storm Prediction Center in Norman.
I've been in meteorology for almost 25 years, forecasting, and it is mind-boggling to sit back for a moment and think about the advances that have been made in just that short period of time. But the ability to forecast a tornado event prior to an actual thunderstorm forming is an ability we still don't have.
Although almost every tornado begins with a thunderstorm, not all thunderstorms produce tornadoes. The difficulty is predicting which thunderstorms will be most dangerous.
That's a double-edged sword in meteorology. You don't want to incite panic and talk doomsday scenario, but then again, you don't want to be so careful and quiet that people don't get the word.
The hope of all tornado scientists is to be able to give as much warning as possible. But it isn't easy. Meteorologists are able to predict thunderstorms days in advance by satellites, weather balloons, and radar. But tornadoes are born in minutes. The most effective prediction tool today is Doppler radar. It works by firing microwave pulses at raindrops to reveal their distance, speed, and direction. This distinctive hook shape often indicates that a thunderstorm has started to rotate and could spawn a tornado. It kickstarts the whole process of alerting communities at risk. When a tornado warning is issued, the amount of time that elapses between a warning and when the tornado strikes, if it does, is called lead time.
By lead time, we mean that the tornado will hit your place in X minutes.
The amount of lead time was crucial to saving lives in Moore.
There could have been hundreds of people injured or killed in this tornado had there not been good warning, had the people not known what to do in case a tornado was coming.
Many people in Oklahoma have storm shelters, but most schools don't. At the Plaza Towers Elementary School, the tornado took its most terrible toll. Nova's cameras are the first to go inside. In this school, 7 children died when the storm tore through. But the tragedy could have been so much worse.
We had about 15-20 minutes to prepare for this, if that. We sat in the hallway, and you get on your knees and you bend over your knees and you put your hands behind your head. All of us teachers took a deep breath and was like trying to figure out, okay, what are we gonna do now? And we just hunkered over our kids and we laid on top of our kids and we did whatever we could.
4 of Maylene's children were elsewhere in the school, including her daughter, Tori.
When it hit the one part of the school, I heard my teacher, Mr. Ayers, he screamed, get down, it's coming, get down.
Then you hear the building being ripped apart and you hear glass shattering and you can't breathe because it's blowing and sucking the air out of the room, and it felt like in an eternity the building was collapsing.
Everyone started crying and screaming, and the next thing you know, the roof comes off.
In the immediate aftermath, Maylene saw the obliterated school, not knowing if her kids were alive or dead.
So we were shimmying out of there trying to get up and make sure our students were okay, and they started screaming and crying, and we knew at that point that they were okay. And we kind of looked around, and there was actually a car that had gone into the teachers that were over here with their students, and so they were pinned under rubble.
After checking that her students were safe, Maylene frantically searched for her own 4 children.
I ran down to the other part of the building and climbed back in the building. Probably took about 30, 45 minutes before I actually saw my children. That was probably the best feeling that I had had all day. They just came running, and we embraced, and I told them that I loved them.
After this tragedy, Oklahomans are discussing how to make schools safer, and scientists continue their efforts to understand these killer storms. But like the weather itself, tornadoes are complex and varied. It's difficult to come to grips with the nature of these violent storms.
A tornado is a rapidly rotating column of air.
It's in connection with both the ground and also the base of the thunderstorm.
Cold air descends with rain and hail and wraps around the circulation.
And if they concentrate that circulation in certain areas, you have a tornado.
This is a typical tornado spawned from rotating winds and a thunderstorm called a supercell. Most tornadoes are small and broken, with wind speeds less than 110 miles an hour. The most extreme tornadoes are 2 miles wide, with 300-mile-an-hour winds, and capable of traveling hundreds of miles.
We certainly know what a tornado is. However, the big mystery is trying to discover why a tornado forms. We don't understand why some thunderstorms produce tornadoes and others don't. Only a very small fraction of them, 10% or perhaps even fewer storms go on to produce tornadoes.
Important clues can emerge from studying the pattern of destruction. So amid the aftermath of the Moore tornado, Howie Bluestein takes to the skies.
From the air, you can really see it. From the ground, you just don't get an appreciation card. Now we're passing through the damage again. Again, the damage path is like 3 houses wide for heavy damage. Oh, this is just awful to see. This must have been where the tornado was its most intense and where the tornado was its widest. A world-class tornado, I think.
And this isn't the first time that the people of Moore, Oklahoma have experienced this kind of death and destruction. May 3rd, 1999. And one of the most powerful tornadoes on record makes a direct hit on the city. Winds topping 300 miles an hour destroy 8,000 homes, causing $1 billion worth of damage and leaving 46 dead.
My God.
In May 2003, the unthinkable happens again. Another major tornado heads straight towards Moore. Although no one is killed, dozens are injured, and homes, businesses, and factories are wrecked.
Here is a composite of the 3 significant tornadoes to strike Moore in the last 15 years.
All the radar images have one striking feature in common, a distinctive hook showing that the clouds are rotating, the precursor of a tornado. Gary England, chief meteorologist of Channel 9 TV, has decades of experience issuing vital warnings in the state where tornadoes strike terrifyingly often.
Geographically, we're right in the right spot. Somewhere, there has to be a point that is most favorable. And apparently, based on history, it looks like it's in Moore, Oklahoma.
For whatever reason, Moore seems to be ground zero in what is known as Tornado Alley, the central portion of the country between the Rocky and Appalachian Mountains. Every year, from mid-April into the summer, Howie Bluestein ventures out into this vast expanse, chasing tornadoes with his advanced mobile radar. His goal is to understand the inner workings of tornadoes, and this is his lab. But what is it that makes this region so dangerous at this time of year? It starts with cold winds coming in.
During the springtime, we have air coming in at high levels in the atmosphere. Comes in and it goes up and over the Rocky Mountains, and it subsides and it warms. And that makes southerly winds out over the central part of the United States. And those southerly winds bring in a relatively warm and moist air off the Gulf of Mexico and overspreads the plains area.
This creates huge thunderstorms. Then winds coming in from different directions produce spin.
The winds turn with height, and they become a lot stronger with height. So we have a source of rotation within the storm.
The Moore tornado is noteworthy, partly because it appeared in a relatively quiet season. 2012 was also quiet, likely due to drought conditions. But 2011 was the fourth deadliest tornado season on record. In April, the start of that season, Howie Bluestein and his team are out in the plains of Oklahoma, testing their new mobile Doppler radar. So far, all is quiet. But 100 miles away, in another part of Oklahoma,
I'm calling to report a tornado. It is on the ground just west of Stroud, Oklahoma.
a tornado touches down in Stroud, the first of many in this area.
Oh no. Oh no.
The average tornado lasts 2 to 3 minutes, but some keep going for 10 minutes and even longer.
Whoa, that's violent. That's incredible.
Over several hours, Alabama, Arkansas, Mississippi, Oklahoma, and North Carolina are all struck by tornadoes. A strong storm over Tushka, Oklahoma starts to rotate, becoming a tornado, killing 2 people. But that's just the beginning. Over 2 days, over 200 tornadoes touch down in 16 states. 38 people lose their lives, from Texas to North Carolina. This is a shocking start to tornado season. Described as one of the largest single-system tornado outbreaks in U.S. history. Scientists are asking, is it an isolated incident or part of a pattern?
We saw a number of these events. We saw around the 16th of the month a major tornado outbreak in North Carolina. The questions became, can we predict that this pattern will continue?
To answer that question, Greg compares the April 2011 outbreak to previous seasons.
We actually have a system that will take a forecast and it will compare that forecast to historic weather events of the past. So there was a good analog for this event that had occurred in the past to the forecast pattern that was coming up in the days ahead.
When Greg examines his data, the result is not reassuring.
The match that came up was a Veterans Day event of November 2002. Nearly 40 fatalities associated with that event. Kind of an unusual time of year, not the spring, but actually the second, what we call the second season of activity.
Fall 2002 saw 76 tornadoes sweep through 17 states. Greg is concerned that the position of the jet stream, the river of air that circles the Earth high in the atmosphere, is affecting the weather. It's shown here in blue.
This is the November jet stream pattern that was in place in the year 2002. And we can see the Similarities with this event in 2011, jet stream diving across the Rocky Mountains and driving intense thunderstorms across the southeast Tennessee Valley and Ohio Valley. I sent email out to the National Weather Service, publicly available through our website, talking about the fact that the upcoming event showed signs of similarity to the outbreak that we saw in November 2002.
There's cause for concern. Some meteorologists believe it could be even worse than the 2002 Veterans Day outbreak. A tantalizing clue lies off the coast of Peru. The Eastern Pacific, July 2010. Ocean buoys record unusually cold sea surface temperatures. This is called La Niña, and for centuries, Peruvian fishermen have been aware that it not only affects their fishing, but also the weather. Scientists can now measure the effect. Here's the way a La Niña looks on a satellite's thermal imaging camera, showing the cooler sea temperatures off the coast of Peru in green. Scientists discovered that the huge expanse of cool La Niña water could affect the surrounding atmosphere and the jet stream, shifting severe weather into new areas and intensifying it in places like the southern United States.
We had a very strong La Niña in the wintertime that set up a strong jet stream that provided the wind speed energy that was necessary to generate thunderstorms. But we also then had very humid and moist air in the southeastern part of the United States that provided the fuel for these thunderstorms. And the combination of those two provided an environment that was more conducive to these large tornadic outbreaks than you might have in other years.
By spring 2011, the newly intensified jet stream was already contributing to rainfall and floods across the South. Plus droughts and raging wildfires in Texas. Warning signs of historic weather extremes.
We were worried about it because when you have a La Niña, as our research has shown, there tends to be more family outbreaks of these tornadoes in the southeast United States.
In fact, one of the worst tornado events in history, the super outbreak of April 1974, also took place in a La Niña year. 148 twisters touched down in 13 states, from Mississippi all the way up to New York, killing 330 people and injuring thousands. But will the pattern hold in 2011?
It's crossing the interstate right where we were.
On April 25th at 7:25 p.m., violent storms in Valonia, Arkansas, launched the largest outbreak ever recorded.
Here comes the rain. Boom.
The worst day is the 27th of April, starting at 2:30 p.m.
A large, violent tornado that is down on the ground.
A powerful tornado touches down in Philadelphia, Mississippi, and kills 3 people. Then Cullman, Alabama is struck, leaving 6 dead, followed by Hackleburg, Alabama. 18 are killed. 4:45 p.m., Tuscaloosa, Alabama. Classic anvil-shaped clouds form supercells, thunderstorms where rotation has begun, as Greg Carbon observes.
I came out into operations during the late afternoon. You were seeing incredibly well-formed supercells, the likes of which was truly stunning.
A distinctive hook echo, the radar signature of a fiercely rotating storm, heads toward Tuscaloosa.
With every one of those hook echoes, you had a violent tornado on the ground.
This is a large, violent tornado coming up on downtown Tuscaloosa. Be in a safe place right now.
A 1.5 mile wide tornado cuts through the heart of Tuscaloosa, leveling entire blocks and tossing trees and power poles around like toothpicks. Tornado scientist Chris Weiss recalls.
The A storm that affected Tuscaloosa actually initiated back in Mississippi. Actually traveled for, I think, a good hour and a half, and then produced its tornado. Stayed on the ground all the way up into Birmingham. The storm itself actually lasted 7.5 hours because of the various dynamics with the storm, producing tornadoes along a good chunk of that length. You see regions all across northern Alabama into northwestern Georgia, even up into western North Carolina. Tennessee was also affected. So a tremendous number of tornadoes for this outbreak.
In Oklahoma City, TV meteorologist Gary England follows the path of the storms on radar.
We watch them from here. We can look at the radars, and you can see the tornadoes developing, you know, massive supercell thunderstorms, big rotations inside. The rotation sometimes becomes the entire tornado, and that's what was happening down there, and it looked like a fleet of them. They were just coming across there.
The outbreaks of 2011 gave tornado experts vital information about the devastating power of wind. Although disaster investigator Tim Marshall sees it often, he is always shocked.
I have always been surprised by the power of tornadoes. I mean, after all it is air and water, so how dangerous could that be?
Investigators like Tim use a system called the EF scale to measure the strength of tornadoes by rating the damage they do.
Typically every year we get 1,500 tornadoes in the U.S. EF0 is damage to tree limbs, some shingles off of a roof or so, and then EF1 is more substantial damage like some roof decking.
And EF1 can often be powerful enough to overturn a mobile home.
EF2, the roof is gone.
The aftermath of even an EF2 can look like a bomb exploded.
EF3 is basically the outer walls of the house are down and only the interior walls remain.
And EF3 releases the same energy as 10 tons of TNT, like the tornado that hit Canton, Oklahoma in 2011.
EF4 is basically all the walls are down with just a pile of debris left on the foundation.
Very little is left standing after an EF4 tornado. This EF4 hit Shawnee, Oklahoma, May 19th, 2013.
And EF5 is complete sweeping clean of the foundation, of the house, of all the belongings, such that there's only a little perimeter left in the ground where the house once was.
An EF5 is equivalent in bomb damage to the atomic bomb dropped on Hiroshima.
To have an EF5 go through a major metropolitan area is rare. I mean, less than 1% of all tornadoes get to be that strong and get to produce that kind of intense damage.
But EF4 and EF5 storms combined, just 1% of all tornadoes, produce 70% of all casualties. The tornado that hit Moore in 2013 was categorized as an EF4 at first. It was later upgraded to an EF5. So what led to this massive tornado? There were no cold La Nina conditions in the Pacific. But earlier, the jet stream had shifted further south than usual. When it finally moved back north, it allowed warm, moist air from the Gulf of Mexico to surge across the Oklahoma plains. Perfect fuel for supercell thunderstorms that spawn tornadoes.
We will rebuild. We will stay here. We're not going anywhere. This is our home.
This one killed 24 people. A stark reminder of the need to increase lead time to get people to safety. It used to be a lot worse.
It's a clear wedge tornado, Gary. About a quarter-mile wide wedge tornado.
As Gary England recalls.
You know, when I first came here in 1972, the lead time on how early could we get a tornado warning out was probably about -2 minutes. The warnings in those days were just absolutely terrible. The equipment wasn't too good. Radars were nice, but just nothing to go with, no computers. And I could only warn you because it blew someone else's house away down the street. That's how bad the warnings were.
Sit down.
This 1950s government film on tornadoes illustrates how limited tornado warnings were.
I gotta keep watching the southwest side. It's where most of them come from.
You think it's likely?
No. The odds are way against it, even in weather like this.
Forecasters had to rely on ground observations and weather balloons to tell them if storms were coming. In the 1960s, satellites were launched to observe cloud formations and give readings of Earth's temperature. But when Doppler radar was introduced in 1973, scientists could clearly see the hook echo, signaling that rotation had begun. Powerful computers that could analyze vast amounts of data helped get the tornado lead time to today's 13-minute average. This has saved many lives, but could it be better? Most forecasters believe that a breakthrough will only come by unlocking more detail on exactly how a tornado forms. Howie Bluestein and his team intend to do just that. They've installed a new Doppler radar to carry on their truck. If they catch a tornado, it could get them enough data to refine the computer models that they use to predict future storms.
What people are trying to do is to take weather data and put it into a numerical model, and then let the numerical model produce tornadic thunderstorms. So then you can issue a forecast and say, there's a 20% chance that in your neighborhood, 4 hours from now, you might get a tornadic thunderstorm.
The main question concerns rotation, as Chris Weiss explains inside a tornado simulator at Texas Tech.
To get a tornado, we need that storm to acquire supercell attributes. That just means that the wind is coming from different directions and speeds with height.
The supercell storm starts with air crashing and spinning, mostly in a horizontal direction. To turn into a tornado, it needs to go vertical.
We need to have an updraft, an area of very quickly moving air, pulling the air upwards very quickly. And what that does is it takes the spinning air and it stretches it in the vertical. So you can imagine that, say you had one of those Chinese finger trap toys and you pull on it on both ends, it constricts that axis of rotation and makes it spin faster. That helps us explain most of how tornadoes form, though we don't have a good handle necessarily on the mechanisms that create that spin near the ground, though. And that's where a lot of the research is focused at the moment.
So vertical spin is only part of the picture. What else can turn a rotating thunderstorm into a tornado? If scientists can work out other possible factors, like wind speed, temperature, and pressure, they may be able to, in effect, reverse engineer a tornado.
This is a supercell that's moving to the southeast. I cannot discern any rotation visually, but we need to keep an eye on that.
Out on the plains of Oklahoma in late April, Howie is hoping to get close to a tornado with his new generation of mobile radar equipment. This is dual polarization radar, a state-of-the-art system for peering more closely than ever before into the heart of a tornado. The vital new development is that this radar can spot not only raindrops, but also debris blasted into the air by a tornado funnel. Howie's system is a mobile one, but dual polarization radar is so effective that it has now been installed throughout the network on fixed radar stations.
Dual polarization radar can tell us information about the stuff that the radar beam is scattering off. So we can tell a small raindrop from a big raindrop, from a hailstone to a flying cow, to a piece of a flying board. And that's extremely important from the standpoint of warnings, because if a radar operator sees that not only is there a vortex, but there is an indication of debris, then you can be pretty sure that there's a vortex acting on the ground.
2011 gives Howie the opportunity to try his new equipment. But first, he needs a tornado.
There's a funnel cloud due west of us. It doesn't appear to be very intense. There are also a cluster of 3 cells to our northwest, and they look fairly good on radar, not great. So we're just going to sit here and wait. Oh, wow. Holy mackerel, we've got 3 hooks. Yeah. We have 3 hook echoes right now, 3 potentially tornadic storms.
The team has managed to place the radar in the path of a storm, picking up hook echoes, which signal the storm is beginning to rotate.
And the southern one is coming fairly close towards us. It's a good thing we stopped.
It looks like it could be evolving into a tornado.
Hope we don't have to move. That's remarkable.
Half an hour later, the tornado is forming, and Howie's radar is recording it all.
This has never been done before. A relatively complete look at the evolution of the tornado as it was beginning, as it was intensifying, as it became very strong.
Then one of the most active seasons on record seems to die out just at this point.
After a record April, as far as tornado events, we were headed for a record May as far as the fewest tornado events on record. And then Joplin.
Joplin, Missouri, May 22nd, 2011.
Oh my gosh. Oh my gosh.
The deadliest tornado since 1947. Emerges from some unique weather conditions.
The thunderstorm that produced the Joplin tornado began in Kansas.
Forming at 2:30 p.m.
Southeast winds came in from the surface, and up aloft there was southwesterly flow. And this action here produces a spin.
Then, higher than normal ground temperatures produce an updraft of hot winds.
And that updraft tilts that into the vertical and produces this counterclockwise rotation.
At 4:15 p.m., rain and hail begin to fall.
Cold air descends with rain and hail and wraps around the circulation. And as it crossed the state line between Kansas and Missouri, just west of Joplin, a tornado was born.
The tornado is spotted on the ground at 5:34 p.m.
It's a massive tornado, massive destruction. Oh, these poor people. I know, I know. Yeah, south side of Joplin's gone. It is like an F4. It's gone. It's gone. There's people in there. I know. Come here. People everywhere. Hello? Hello?
It also left more than 150 people dead and was the costliest tornado on record, causing damage worth $2.8 billion. On the ground, Tim Marshall studies the debris for any evidence the winds left behind.
I look for clues that indicate how strong the winds were. So that weighs many hundred pounds right there. The heavy weight of this concrete parking curb being moved like that tells us that the low-level winds were very strong.
The Joplin tornado is so powerful, it twists the local hospital 4 inches off its foundation. Most houses suffered much greater damage.
The tornado's only in contact with the house for a very short period of time. I mean, this all happens in 30 seconds to a minute. So the heavier your building, the better, and the more apt that you're able to survive it. If you're inside a car and you're close to a window, you can be sucked out of the vehicle by the differential pressure.
Even light materials on the loose can be deadly.
Now, a piece of cardboard's pretty flimsy, but if a piece of cardboard is traveling at 200 miles an hour, then it can go right on through things like this. It can go right on through the human body.
The tornado that hit Joplin, killing more than 150, was rated as an EF5. In contrast, the Moore tornado of 2013 also ranked as an EF5, killed only 24. Since that tornado struck, scientists have been trying to understand what accounts for the difference in the death toll. One of the most important factors may be the people themselves. Living in the heart of Tornado Alley, the people of Oklahoma are used to living with tornadoes. Many have storm shelters or safe rooms, and they take warnings seriously.
Oklahomans are very aware of what's going on in the weather. They stay weather aware. I think most of the audience understands what we're talking about, because a lot of times I'll say we have a big supercell. They know that's a rotating thunderstorm usually, and usually a supercell has that rotation in it. I think they understand it. They love the weather here. Well, you know, if they don't pay attention, they die.
Went to the TV, turned it on. Gary England was on there.
Right now, it's along and just north of Interstate 40.
They were tracking the tornado, so I went to the kitchen window and I looked out and I saw it. And that's the first tornado I've ever seen in my life.
I would strongly suggest you take your tornado precautions. This thing has produced a huge tornado.
I went to the safe room, and I was in there maybe 30 seconds when it hit.
The safe room in this house saved the lives of 8 people.
The way that safe room is designed, the structure of it, to tie the structure of the house together is the reason these walls are standing right now.
Even in the latest 2013 disaster, Gary's warnings would play a vital role.
The first time that we saw a tornado or heard about the tornado touching down was with Gary England on News Channel 9. They just said, tornado down, everyone needs to take shelter. If you're not underground, you will not make it.
What was amazing to me was the rapid growth of the system from basically, you know, at EF0, probably 65 mile an hour, all the way to close to 165, 150, 165, in just a matter of minutes.
Staff at the Moore Medical Hospital scrambled to move patients and staff to safety. Through her office window, nurse Sean Bray Johnson could see the tornado heading directly towards them.
This right here is actually our waiting room. If we did not move the patients, they would clearly be dead right now. I got trapped when it came and it hit us. We were stuck in a little pocket, enough for us to be able to breathe. We still had our phones, so we called 911. So I just started kicking walls. I just heard someone say, I hear something, if you're down there, scream.
Amidst the devastation, Sean Bray bumped into the savior who answered her cries for help.
Thank you so much. Oh, God. We did not think we were going to make it out of that building. I was able to walk away. It was a relief to my children when I saw them. So it's a blessing.
The collapse of hospitals, homes, and schools in Oklahoma has highlighted the need to strengthen buildings to withstand deadly tornadoes. So by simulating the effects of tornadoes, scientists at Texas Tech are trying to make structures more robust.
It boils down to cost. We could design a building or a structure that would withstand a tornado. The problem is that most of us couldn't afford to live in that structure. The tornadoes that we simulate in here are based on the mid-EF3 range because about 92 to 94% of all tornadoes fall in that range. The reason why we're doing that is we would like to understand the wind loading on structures such as this scale model of a mobile home. Our preliminary work shows that you have parts of the structure that experience a positive force. In other words, they're trying to push the force in. And then as the tornado gets closer and closer, then you have suddenly parts of the force that is wanting to pull it apart. The other bad part is you have stuff falling down from your roof.
Structural engineers at Texas Tech are also looking at debris impact, trying to replicate the forces of the worst tornadoes, like the EF5 that hit Moore, Oklahoma.
Tornadoes can send all kinds of debris, impaling buildings, livestock, people, cars. It's phenomenal.
Ultimately, we would like to develop codes that say if you live in these tornado-prone areas, you ought to think about reinforcing structures in this way or building a structure in this certain way. That's the ultimate goal.
As the 2013 tornado season with the devastating Moore disaster winds down, scientists and communities at risk are grappling with further questions. Will destruction at this scale become more frequent?
The reason why tornado disasters are on the upswing is that more people are getting in the way. As our cities expand, the target gets bigger. So tornadoes are more apt to hit major cities now than they were 100 years ago. And that can only increase in the future.
And does global climate change mean it's going to get worse?
As the climate warms up and the amount of moisture near the ground increases, that certainly is something which is favorable for producing more thunderstorms.
Probably there's a relationship on the large scale to a warmer climate. We also know that there's a potential for more moisture in a warmer atmosphere, and we are seeing extreme precipitation events occur more frequently due to that.
The Moore, Oklahoma tornado was a major disaster. The first EF5 top-of-the-scale tornado to strike the U.S. in 2 years. The loss of life will never be forgotten. Yet it was less than might have been expected. Tornado awareness, better shelters, and increased lead time will continue to save lives. Research on Oklahoma's plains and new scientific equipment promise further improvement. No human force can ever prevent tornadoes. But a better understanding of them may yet soften the toll from these winds of almost unimaginable power.
Major funding for NOVA is provided by the David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. The Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you. The Boeing Company, and by NOVA, Oklahoma's Deadliest Tornadoes, is available for download on iTunes. Other NOVA episodes are also available.